Procedural materials suck. Everybody knows it. But let's change that. Today you'll learn how to make this procedural cobblestone. You can change the number of stones, plants, etc. and it's miles ahead of anything I've found online. I used the same technique to make these materials, which shows you how versatile it is. And they're all made 100% in Blender, but here's the catch. They're not made in the shader editor. This material is not made here. It's made here, using sculpting, geometry nodes, normal Blender stuff. And then it's rendered out in a particular way so that you get base color maps, roughness, normal maps, and so on. Super simple. All the big studios already do it. Here's how to do it in Blender. Alright, first thing, I'll add a mesh plane and just make sure that that plane is 1 meter in each direction, so I have some real easy units to work with. And to set up the tiling part, I want to add a couple of collections. So I'll just add one collection more, and this first one, that'll be called Texture, and the second one I'll call Tiler. And in the Tiler, I'll add another object. Doesn't matter what it is, because we're going to slide over here into a geometry node editor, press New, call it Collection Tiler, and delete the group input. Now, what I want in this input is a grid. So I'll Shift A, search for grid, and then preview that, Shift Z, and you'll see what this does. It has 3 vertices in each direction, which is exactly what we want, and we want the size to be 2. Now we can instance on those points the whole of the texture collection. So just press that, pull it in here, and pull it into the instance. Now what is going on is the plane that is here in the texture is instanced around itself. So any change I make to that will be instanced around. However, there's a problem, and that is the middle one is there twice, because the tiler is actually instancing that as well in the middle. And we need to delete that point. To do that, we'll just add a delete geometry node right after the grid. And the point we want to delete is any point that has a position equal to 0, 0, 0. Very easy. Just put that result into the selection, and that cuts a hole in it. This is exactly what we want. I'll just rename this object to Tiler, and so I don't click it by mistake, I'll just turn off the selectability of it. And if you can't see that, go into the filters here and turn on selectable. Now I can't click it, I can only click the one in the middle. Now in the uppermost collection, called Scene Collection, I'll add a camera, which I'll move on the Z axis, holding Control to snap it, and just move it 2 notches up. That puts it on Z 2 meters, and that's actually kind of important, so remember that. I'll press Alt-R to reset its rotation, so it's pointing straight down, and go into the camera properties. Change the type from perspective to orthographic. We don't want any perspective shifts on this. And the orthographic scale to 1. I can look through this camera by going to the 3D viewport here and pressing Ctrl 0 on the numpad. And to make it match completely, the output resolution has to be square. Now, for these material scenes, I really like to use a 4K resolution as the default. That's 4096. And if I want something lower, I'll just turn down the percentage here. So 1K would be 25, for instance. Now back in the camera properties, I'll just go to viewport display and turn up the pass part 2, so I can't see the tiling, that's distracting, and I'll also turn off the gizmos and overlays, which I also find distracting. Now if I put anything into the texture collection here, like for example a monkey, you can see that when I move this off the edge of the camera in one direction, it comes back in the other. And this is the behavior that we want for perfect tiling materials. Now I want to see these rendered, so I'll just turn on rendered view. And I do want 2 types of lighting to view this through. So I'll just go into the shader editor and the world. One of the ways I want to see this is a completely even lighting, exactly like this. But the other way is I want to actually be able to preview the 3D shape of this, and that's really hard using an even lighting like this. So I'll duplicate it and press Ctrl T. That works if you have the Node Wrangler add-on enabled. And I'll find an HDRI that is kind of neutral, like this, and just preview that for the time being. Now with all of that set up, it's time to make the material itself. And to begin, I'll just go into the plane actually, and I'll rename that to ground. And in that ground, I'll just add a new material called something like dirt. And I'll give it a dirt material. I have this one downloaded, which is called Mossweed Covered Damp Creek Bed from Substance. And it looks like this. Something that also really helps to just elevate your material a little bit is to use a displacement. For displacement to work, you need to go to the material properties into settings and change it from bump only to displacement and bump. And also you need to subdivide your plane. So I'll add a subdivision surface, change it to simple so it doesn't round off, and I'll get something like 8 subdivisions, something like that. And it's obviously, it doesn't look exactly like grass would, but probably a scale of 0.01 will be fine. And the way it now kind of undulates will help it blend a little bit better with everything we're going to add later. Now, I do kind of want to scale this. I feel like it's a little bit too big, but you gotta watch out when you're working with tiling materials because you need to stick to whole numbers. If you go 1.5 on the scale, for instance, you will see visible tiling at the edge. It won't actually line up, but if you stick to whole numbers like 2, it'll perfectly tile no problem. I'll shade that smooth because I'm seeing some faceting. Now let's add another collection to the scene collection. I'll just call this assets. And in here, I'll add another collection called Cobblestone. And in there, I'll just paste some cobblestones that I have open in another file. So I'll turn off these cobblestones, and in the texture, I'll add another object. Again, doesn't matter what object. I'm going to go into geometry nodes and add another one called Cobblestone. And in here, I'll just add a grid where I'll instance on those points, and the instances are going to be the cobblestones. Again, pick the instances, separate the children, and then when I turn up the instances, you'll see a bunch of the cobblestones. Bunch of problems, though. Bunch of problems. Let's just start at the beginning. For one, you'll see a bunch of stacked cobblestones at the edges. Here's one, here's one. Actually, all of the ones on the edge are doubled. And the reason for that is it is instancing at the very edge, and then it's tiling. It's viewing that back over here. And here it's also instancing one, so it's doubling up, meaning we have to remove all the stones on one edge on the Y and X axes. And we do that in the same way that we deleted the center point earlier. The way is delete geometry, and we do it based on position. But this time we need to separate the X, Y, and Z, and we need to say if the X is greater than or equal to 0.5, or the Y is greater than or equal to 0.5, any point that satisfies those criteria will be deleted. And if I press that object, and you can see this was before and after, before and after. That just shaves those off and fixes that problem. Another problem is there's no random rotation here. And we can add that by going to the instance on points node, pulling out from the rotation and typing random. It's not as easy as that though. First problem is rotating on all 3 axes. Not realistic. So let's turn the X and Y to 0. Now it's only rotating on the Z. We want them to be able to rotate 360 degrees. And in vector speech, that is TAU. That's the word for 360. That is pi times 2, the number pi. And now let's snap it to 90-degree increments. So pull out from here and just type snap. And if 2 pi is a full rotation, what is a quarter? Well, it's pi divided by 2. Pull that into the rotation, and now they're snapping to 90-degree increments. So now I'll just scale them up a little bit to decrease the gap between them. I'll move them down so we can see the ground a little bit better, going below them, and I like this kind of overlap that we're seeing here. Let's offset every other one. Here, after deleting the edges, I want to set position of the points. And which ones do I want to set the position of? I want to do that based on the index of them. And if you run that number through a modulo set to 2, that is if you actually have an even number of stones, which we do in each direction, because remember, we're doing 9 by 9 and then deleting the edge, so we in effect have 8 by 8. And that is important for this to work. And now we're targeting those with this here. What do we want to do with that? We want to multiply it to control how much we want that, and we want to combine x, y, z to say on which axis do we move them, and we move them on the x. Plug that into the offset, and now this multiply value will offset every other stone. This workflow depends a lot on having good assets, rocks, planks, textures, and one place to get those is BlenderKit, which comes as an integrated add-on in Blender. Now, I wasn't sure about BlenderKit's quality at first, I'll be honest, but that was before I tried the paid version, and the difference is huge. Like, it's honestly night and day. So I asked BlenderKit for a discount code, and they came through. So use my link in the description and code SQUARES at checkout to get 10% off in addition to the 33% off you already get because they're having a campaign right now. Yes, the discounts do stack. So if you sign up before December, you get a 43% off for the rest of your BlenderKit subscription. If you're considering trying BlenderKit for this workflow, now's the time to do it. For me, the next step is to add some plants, and I want to add plants between all the cobblestones, which is surprisingly difficult. So here, I'll just call this object cobblestones without the giant O. And in the texture, I'll add another plane. And this time, I will keep the group input and distribute points on it. Just for demonstration purposes, I'll just turn this up to something giant like 1,000 and then turn down the radius of those points so we can see through them. And I'll turn off the render for this. So I do not want plants to grow on the rocks. I want them to grow between. And to do that, you might think we use a raycast, and you'd be right, but it's not quite that simple. Let's add a raycast node and cast a ray to see if it hits a rock. What we want then, obviously, is we want to pull in the cobblestones object, set to relative positioning, and pull that into the target geometry. We're casting to see if we hit the rocks. Where are we casting from? Well, right now we're casting from these points, but some of them are inside the rock, some of them are not. It's going to be unpredictable. So let's just manually set the position to the position of the point, but just add a meter on the Z. So we're just casting from above. And we are casting in the direction of down. That's correct. And if it is a hit, then we delete the point. This does not work because what we plugged into here is a bunch of instances, and it doesn't work with instances, raycasting that is. So let's realize those instances. And now it actually does seem to work. We're getting points between the stones and not on top of them. It is working right up until we get to the top, where it's not working again. Why is that? That's because these stones are not part of the cobblestone collection, remember? They're part of the tiler. But we cannot just raycast at the tiler, because the tiler is tiling everything that's in the texture collection, which includes these plants themselves, so you'd get a dependency loop. So the way we fix that is we retile just the cobblestones. Here's how. I go back into the tiler, and I just take this collection info, I pull it way out, select everything else, and press Ctrl-G to group it. This is now a group I can reuse. And I'll call it Tyler. Now back in the plane, which I should rename to plants, I can get that Tyler and tile these cobblestones over again. So I'll tile them, but remember this Tyler deletes the center tile, so I'll also join geometry and join it back in with the original, and then realize everything, and now that fixes the problem. So now I'm getting points only in the crevices between the rocks. Perfect. So let's instance something on them. In the assets collection, again, I'll just add a new collection. This is the weeds. And just like I did with the cobblestones, I'll just copy those in from a separate file I have open. Turn off that collection, move the weeds into the geometry nodes, and instance them on the points. I'll separate the children and pick instance. Let's turn down the scale of each one. And in fact, I'll turn down the density as well. Something like 500 should probably be enough. I'll turn back on the renderer so we can see what we're doing. That looks pretty good. Let's add some random rotation to them. Random into the rotation. Nothing on these two axes. And if you'll remember, tau on the z-axis. I'll also add another random value. Now, when you use multiple random values in the same graph, you want to change the seed so they're not the same, because whenever it picks one instance, it will also select the same random value for the rotation and the same random value for the scale, so one instance will always be the same rotation and scale. And since I'm using this for the scale, remember, I want the scale to be uniform across all three values, which is why I'm not using a vector in the random value, I'm using a float in the random value, which will make it uniform. And the max value should just be 0.5, I think, and the minimum value can be 0.2. Now, I don't like how much they're intersecting with the rocks, so I'll move everything up. And I'll do that after the deletion, just for optimization's sake. So I'll set position of every point in here, and I'll set it to 0.01 meters up, just to clear them. Now to check that the tiling is working properly, I'll go out of the camera and view this whole thing from the sky. And it's fine, but if you don't like it, you can go to the distribute points node and change the seed until you get a distribution that doesn't super visibly tile. Now let's just say I'm done with this material. This is the way I want it to look, and now I need to render it out. How do I do that? Let's actually start in the compositor. So I'll just change this to the compositor window and press home to frame that. And I can actually delete the composite output and replace it with a file output node. To get the settings for the file output node, I'll press N and go to its node, and under properties here, you can see all the inputs it gets. And what do we want? We want a base color. That's a given. We also want a metallic, a roughness, a normal, and a displacement. You can do anything, but let's just start with these. Now for the file type, if you know me, you know I'm gonna go for an OpenEXR, RGB, half float, DWAA compression. And for this, I want to override the color management as well and replace it with a linear Rec 709 color space. Actually, future Robin here, I end up setting this to sRGB later on. That's just to make the tutorial a little less complicated. So not linear Rec 709, sRGB. Okay. However, some of the outputs can do without this. For instance, the base color, I don't feel like needs this kind of color depth. So I'll turn off use node format for base color, and I'll just change it to JPEG. JPEG, 100% quality, and follow the scene color management, which will just copy the color management from the render settings over here. Now, what color management do I want to use? I'm generally a huge fan of AGX. For textures, though, I really like the new Chronos, because it really keeps the punchiness of the colors, which I like. How do I get the base color out? Really, I just want the image to go into the base color. Whatever's rendered, I want that to go into the base color. And I don't want to bake in the lighting, so I'll go to the world settings, and instead of using this HDRI, I'm going to use the even white lighting. Now in here you can do some color correction. I think this looks really yellow just because of the materials I've chosen, but I'm going to blue that up a bit. That's fine. And you can also turn up the value to 1 is probably best. And now this is a really good way to get the base color out. With this rendered out is just the base color. Great. Now the metallic, this material doesn't have any metallic, so we don't have to worry about it. The roughness though. How do I get the roughness out of the render? What I need is to get the roughness value from each material into the render. And the way to do that is to use a shader AOV. You set that up in the View Layer tab. Here you go down into Shader AOV, and we'll just add a new one. We'll call this Roughness. And let's just copy that text because we're going to need that exact text very soon. The roughness doesn't need to be a color, it can just be a value because it's black and white. Let's save some data here. And to get the value out from the shader and into here, we go into the shader editor of any of the materials. Let's just go into the Cobblestone's materials and add the Cobblestone material. And in here, I want to add an AOV output node. In here, I'll paste that name. It's case sensitive, in case you wondered. And in this, I'll just pull the roughness straight into this value. Remember, we set it to value, not color, so it's not gonna look at the color input for this. And now watch this. If I press F12, you'll see it renders the image, but up in here, where you see the passes, you also have one called roughness, which is the one we just made. And that now has the value of the stones in it. The rest is black, and that's just because I haven't set it up for the rest yet. But I can do that. Going into the plants, AOV output, the roughness just goes into here, and we call it roughness. Same with the ground. Into here, AOV output, called roughness, and the roughness goes into that. Now when I render, all of the roughness values are brought into the render as well. And now in the compositor, we have another output from this node called roughness, and we can just plug that into roughness and call it a day. Now for the normal, there is a render pass for that. You just go into the render passes and turn on normal. However, you cannot plug it directly into the output, and I'll show you why. If I press F12 now, and I render this. Now let's go into the compositing tab, and I'll add a viewer node so we can view the normal. This here does look like a normal map, but it's not properly formatted. The problem here is you have a spectrum going from 0 to 1, but you also have negative numbers, -1. And this normal map here is going from -1 to 1. Now that's a problem because a normal map goes from 0 to 1. Let's pull out from the normal map and do an add operation. What we'll do, we'll add complete white, which has a value of 1. What just happened? We shifted this spectrum from -1 to 1 to 0 to 2. We just added 1 to it. Now what do we want to do? We want to compress this down again. And to do that, we'll do a multiply operation. We'll multiply by a value of 0.5. What happens if you multiply 2 by 0.5? Well, it moves in here, into 1. So now it's a range of 0 to 1, exactly what we needed. However, we're still not quite there, because this is in linear color, and we need it to be a gamma of 2.2. So we'll add a gamma node as well, set it to 2.2, and if I view this result in the viewer, you'll see it looks a little bit more like the normal maps you're used to seeing. This here is what goes into the normal output. We'll go into its outputs. Do not use the normal output. In fact, you know what? To make this easier, let's use the node format and just change the node format to be sRGB, and we can work with that. So everything here is now in sRGB. The displacement can be very easy, or it can be kind of tricky. What we want is we want a value going from the top of it to the bottom as a linear gradient. And what better way to do that than turning on the mist, because you can actually see that in the viewport by going to this little drop down and selecting mist. And now we can change the range by going to the world tab, mist pass, and saying what is the start of this? And remember, I asked you to remember the height of the camera. The height of the camera is now 2 meters, meaning that going down to 0 is a 2-meter start, except we're starting a little bit above that, and I'd say it's probably, since each of these squares here is a decimeter, I'd say we should start at 1.7. And then the depth of it, we want to calculate all the way down to where the ground is, and the ground is displacing a bit up and down. So let's just say about 0.5. Now we're getting a gradient, and we can start adjusting this, holding shift and dragging the start up until the top is completely black and turning the depth down until the bottommost parts are white. We want as much contrast as we can get. Let's render this so we can see it in the compositing tab. And here I'll just viewer the mist, and let's do a map range node because it is, if you can't tell, inverted. The highest parts should be white, while the lowest parts should be black. So first of all, clamp it, and then switch this 0 to 1 and 1 to 0, which because of these weird values things messes up the range. So I'll just pull down the maximum here until I get that contrast back. And that goes into the displacement output. Now let's render this. And to automatically save everything here, you need to render an animation. I don't want to render an animation, so I'll set the frame end to 1 as well, so it'll stop after rendering the first frame. Alright, here I have a preview scene with everything set up. I'll go into the base color and replace that with the base color I just rendered, which looks good. The color space should be sRGB. The roughness, I'll select the roughness and preview that with Control-Shift left-click, and it looks alright with me. For the normal, I'll add the normal and set the color space to non-color. That's very important. The height should be the displacement, which also looks good. The ambient occlusion I didn't render, but the way to do that is to go into the View Layer tab and turning on ambient occlusion as well. And here I can turn up the displacement scale a little bit. And there you go. That's a material that's really similar to the cobblestone material I showed at the start. Now, if you want to go a little bit deeper, I got some more advanced videos up on Patreon showing how I made these more advanced materials. Go make some kick-ass materials. I'll see you later.